Okay, so which of the following is a non-metal? We have aluminum, magnesium, sodium, and chlorine. I think we know the answer to that. Did you get my pun? No pun intended. No? Nobody? Right there. Okay, so aluminum, magnesium, sodium, they are all non-metals. Okay, they're also by location on the periodic table all very close to each other. That's where they're found. They are considered, yes, they are considered, these are all considered metals. Chlorine is a non-metal. Okay, that would be a question and is a question. 2, what and this is why he also gives you a periodic table that doesn't have the names on it and only has the symbols like this, so he can ask you a question like this. Okay, so what is the correct symbol for copper? CO, no, that's Colorado, lowercase o. So it's definitely not that. CR is chromium. We know Ca is calcium. So the only other option is this one. Okay, so as you can tell, these first 2 questions are relating to what?
Periodic table.
The periodic
Exactly.
table.
Periodic table, intro to the periodic table, stuff on the periodic table. Okay, so you're going to have 1 or 2 questions on periodic trends. Okay, as far as electronegativity goes, we're not there yet. So even though that appeals and applies to the periodic table and the trends of such, we're not there yet. So don't look for that. Okay, we're just going to talk about metals, non-metals. We'll talk about names, element names. Okay, that's all you need to know right now. Yes.
I have a question.
Yes.
So during the mastering assignments, I'm really struggling with drawing things in that weird program.
Yes.
Where you do the bonds and the stuff like that. And I know it's going to get more complicated when we have to draw like the tetrahedrals.
Yes.
Are those kind of drawings going to be on the exam?
No, but there will be Lewis dot structures, but I will show you what those will be as far as difficulty.
Okay, because drawing them in that program, I don't know why it's so hard for me.
No,
but
the program is difficult. Yeah, the program is difficult because you have to pick which atom you're using before you select and make the bond, so it sucks. Yeah, I'll show you. We're going to actually have 2 drawing examples on this exam that we'll go through, and it's very easy, and it uses the same one, that same purpose. Okay?
Can I ask a somewhat related question?
Yes.
So I have had the occasional issue on mastering chemistry where I have the correct answer, except it's not in a format that the program likes.
Yes.
Is that something you could see being an issue on the exam?
No, because he'll already have all the answers, and all you have to select is the bubble.
Okay.
So you won't have, he'll already have it formatted the way he wants it. The only thing you have to do is pay attention to it because there's not subtypes, superscripts or subscripts. So it might look like, and I'll write on here, it might look like this. Right? Instead of we're used to seeing like this. So he might ask you how many hydrogens are here, and you'd have to know that these 2, it's sometimes difficult to see it this way versus see it this way. So that's the only difference in terms of formatting. He might change, but yeah, it's just going to be, read the question, look at the multiple choice, select. You won't have to input anything.
All right, thank you.
Okay. You're welcome. All right, next question. Now we're going to say, which of the following is an example of a heterogeneous mixture? Okay. A, blood. B, sugar water. C, air. And, or D, vodka. Okay, First of all, you need to know what is heterogeneous. So this question is testing your ability to understand terminology. So what is heterogeneous?
It's an uneven mixture. Like they said, an example in the book was like fruit salad.
Right. So if we take it even on a more basic level, heterogeneous mean, and in a fruit salad, you have more than one fruit, right?
Right.
So hetero meaning mix, okay? Homo, same. Homo sapien, human, all human, right? I'm not a heterosapien, cool? That is only in terms of maybe sexuality, but we won't go there because we don't need to go there. But Homo sapien, okay, all human, okay? We're not like half and half, cool? So hetero is a mixture of things. So which of the following is an example of a mixture, a heterogeneous mixture? So sugar, water, is sugar, water a mixture, an example of a heterogeneous mixture?
I'm having an issue, I guess, because like there's two separate things, but they're mixed completely together.
Yes, so that's exactly why I wanted to bring it up. Here's the deal. That, though, is not indicative of telling you if I have hot water or if I have cold water, okay? If I have, like, hot water and I put sugar in hot water, what's going to happen?
It's going to melt.
It'll melt and it'll evenly disperse. So even though I have sugar and water together it's sugar water. The whole thing is completely evenly mixed. It's one thing. It's not like I have multiple things inside there. Okay, and it gets a little bit more complicated when we have cold, and then you can see that, like tea, cold tea and sugar usually just sinks to the bottom, right? But that's more in terms of saturated and unsaturated. So sugar, stay away from sugar in any type of sugary like answer when it's talking about a heterogeneous mixture, okay? Because sugar is more related to saturated and unsaturated in its ability to actually mix in the solution. But we're talking about the overall solution. So air, you would think, okay, well in air we've got carbon dioxide, we have this, we have maybe some nitrogen, but no, it's just straight in terms of air, oxygen, okay? Vodka is distilled, so it should just be what it is once we distill it, straight vodka. Okay, now for the answer for this that he's looking for is going to be blood. And the reason I say blood is because in blood, we've got protein, right? When we put blood and we take blood and then we put it in a centrifuge and we spin it, you can see all these different layers. And it's more than one layer. So it's not just like blood and then everything else. Blood, we've proteins, we've got white blood cells, we've got all these other things inside of the blood. So blood would be considered a heterogeneous mixture, okay? Because it's all together, but we can easily pull apart the parts, and there's multiple things inside of it. Sugar water in this thing is just saying it's all sugar water. The whole thing is evenly mixed, all one thing, sugar water, even though it seems like it's sugar and water, okay? So that's a trick question, and he put one of those on there for you for the exam. So when in doubt, biologically speaking, nursing standpoint, blood, always heterogeneous, okay? Don't overthink these problems, okay? All right, next question, number 4. How many O atoms are in this formula? Dyslexia. Okay, ready? V, O, NO, 3, 2. 5, 7, 3, or 4. So how many O atoms are in this empirical formula?
7.
So we have one here, right? That's always easy. The hang up becomes, what do we do with this? Do we add or do we multiply? Okay. And for some strange reason, on test days, everyone just, it blanks from them and they think to add it or do weird things to it. You just distribute that 2 to both. So 2 times 3 is 6. 2 times 1 is 2. So I have 6 and plus 1. There's a 1 down here. I have 7. Okay. Any questions on how I found that? Okay. Any questions so far on these questions? Are we kind of feeling a little bit alleviated the fact that these are relatively simple compared to what we're seeing on Mastering Chemistry? Okay, this is the purpose of these review sessions, to kind of get you guys back to focusing on what we're going to get at. Now, this stuff is easy because was your first intro to the class, right? We still have a bunch more problems beneath that you're going to see are going to increasingly be difficult. But now, if you feel comfortable with this, then you've technically mastered the content from the first 2 weeks of class, okay? So now we're gonna go to the next question, and this is gonna be a conversion question. So we're going to convert 152 miles into kilometers using sig figs, given, that's what these 3 dots mean, that 1 mile equals 1.609 km. So now what we have to do is we have to set up what I like to call dimensional analysis, okay? We want to use miles into kilometers, right? So how would I begin to do that? You would take your starting value, miles, and for every, this is multiply. For every 1 mile, we get 1.609 km, kilometers. Key here, follow your units. Put your units in. Now this problem is still a multiple choice problem, okay? It still has multiple choice. So A, 245, B, 244.57, C, 94.4, or D, 94. Okay? Miles and miles cross out. Therefore, I'm left in kilometers. So we know that that will be where I'm at. You always will put what you're looking for should be on the top and everything else should be canceling out, okay? Oftentimes this, we'll get there, this original start may not cancel out to get-go because that's what we want to stay in, but we have to use other bits of conversion factors so we can get back to it. So we're kind of doing like a circle, a full circle in our DA for dimensional analysis. But in this point, miles and miles cross out. So I'm just basically taking 152 and I'm multiplying it by 1.609. Now the second part to this question is your sig figs. What is the most amount of sig figs that I can keep in an answer for this problem?
3.
3. And the why? Because we can't be, this is the most significant, this is the most accurate, and this is not, but we can't have an answer that's more significant than this, okay? We have to keep it at 3. So when you go ahead and solve this out, you will get 244.56, which is where you see B, 244.57. And that a lot of people think, okay, well, there's a decimal. Well, kilometers had a decimal, blah, blah, blah. And they'll think that way. No, keep it at 3 sig figs. 244.5, that 0.5 we need to round up. So the answer is A, 245. Okay. As far as math, that's like the most it's going to get, I believe, on this first exam. Okay. What is the coefficient for O2 when the following equation is balanced with lowest whole numbers. Okay, so here is the equation plus O2. All right, so you have to look at this equation in red and you have to balance it. And a lot of people don't know where to begin when they're starting to balance things like this. First that I would do is I would just try and find the least thing, the most solo atom. In this case, that's O2. What I mean by solo is it's not attached with anything. It's just literally O2, right? So here we have 2 atoms. Here we have H and O, that's 2 atoms. Here we have 2 atoms. So, right, so I'm gonna go with the stag guy, O2. I'm gonna always start with the single do, okay? So we have O2. Here I have 2 oxygen, so on my left side I have 2 oxygen. Let's look at my right side, right? So here's my right side. How many oxygens do I have on my right side? 3, right? 1 and 2, 3. So I have 2 over here and I have 3 over here. What's the least common multiple for that?
6.
Exactly. That's a trick that you need to pay attention to. Find the solo atom on one side of the equation. There's always going to be one most of the time. Look on the right side, since that's the products. Count how many we have now. Fix your left side. So to make this O2 6, okay, we would have to put a 3 here. Now the question is asking, what is the coefficient for O2? Even if it didn't ask for that, you already are beginning with this single atom. So the answer is, what is his coefficient? That's not the total number. What's its coefficient?
3.
3.
3.
Okay, perfect. Okay, so the answer is B3, not 6. 6 are the total number of atoms. Okay, we were looking for the coefficient to balance it. Got it? So please make sure that you're reading these questions, because that's how we'll get. I saw so many people pick 6. It broke my heart. Yes, there are 6 oxygens and 6 oxygens, but that's not what the question is asking. It's asking for the coefficient to balance the equation. Okay? Cool. We still feeling good? Do we feel like this is helping prepare?
Yes.
Cool. Okay. Cool. If for any reason you feel bored, hang in there. It's going to get better down below, but I just want to make sure you see each chapter laid out in a possible question. Does that make sense? And you'll see that. You'll be taking these exams and you're like, oh, okay, that's chapter 2. Oh, that's chapter 3. Oh, and now we're on it. You'll be able to see it. It's built that way. Okay? All right. Which of the following is a chemical reaction? So, 7. Okay. A, slicing ham. B, rusting of iron. If you don't already know the answer, talk with me. It's actually just a really weird word to spell. Liquefying oxygen, that's really weird. Okay, this only should get you in 2, there should only be 2 options in here that you might think about. I can tell you right now, it shouldn't be this and it shouldn't be this. What are those doing? How many states do we have?
Like solid, gas, liquid.
Exactly. So if I'm slicing ham, that's a physical change. I'm just cutting a whole ham into pieces of ham, right? Is there any chemical reaction going on there? I'm just changing the state, right? I'm slicing it from a big piece to a little piece, and it's a physical change, okay? Liquefying oxygen, is it still oxygen? Whether it's liquid or it's gaseous, still oxygen. So did I do anything to do? No, I didn't. Nothing changed there in terms of chemical change, okay? That's just physical change, state. Melting of ice,
That's just changing the state
physical
as
change,
well.
right? So, but people think for some reason they elevate it to, well, I put salt on the ice and that melts it, so that's a chemical change. But nowhere in there did I say salt on ice. I'm just talking about ice melting, okay? So it's just a change. Cool? So the only thing that's doing anything chemical is the rusting of iron, because that requires oxygen. So now I'm using oxygen and Fe. Fe for iron, oxygen, and because of that, I'm doing a combustion, and that's why we have rust. Okay? So that is a chemical change. Chemical reaction has to occur. Iron will not rust without the help of oxygen. Cool? Okay. All right. 8. The neutral atom always contains okay, Catherine. Catherine, do you mind if I answer that aloud, or would you like me to do that privately? Okay, so the question was, is baking a cake a chemical reaction? Is it a chemical change or a physical change? Baking a cake.
Physical?
Well, you're adding heat.
We're adding heat.
It's becoming something else, isn't it? It's no longer just a separate ingredients.
So that we're talking, so remember, oh, chemical change. So Lucy, why is it a chemical change? Where's Lucy? I can't see people's names. Why? I don't even know. I just see little faces. I don't see names. How do I change that? This is weird. Grid view? Oh, okay. Alexis. Yeah, okay, I see. So why do you think it's a chemical change?
I think it's a chemical change because you can't get the ingredients back. They turn into something different. Like it changes what it is. But I don't know for sure.
And do people agree?
I would think it would be chemical because you're adding the heat.
Okay, so adding heat doesn't necessarily make it the chemical change, right? Because that's what's doing with your ice melting. You just added heat to melt the ice, and we agreed that that is not a chemical reaction. That's a physical change. So what makes baking a cake a chemical change is because we have ingredients in there that alter what it is. So we're going from even though we're going from a liquidy state to another, we can't get back the baking soda that I put in there. I can't cut open the cake and pull out baking soda. I can't cut open the cake and pull out a particle of the sugar or a particle of the flour. Okay? So we've taken those ingredients and they've completely changed and transformed. Even though heat helped, they've together made a new product that we can't get back out. Cool? So it doesn't matter if there's heat involved. It's because I'm not going to, just like with iron, rusting iron, oxygen hit my iron. I no longer just have iron. I have rusty iron. It's not just pure iron anymore because the oxygen hit it, and I'm never going to get back that piece of iron. Okay? It's forever going to be rusted. Does that make sense? So yes, baking a cake, chemical change. Ooey gooey, blended in a bowl, never going to get that back. Can't even try and fractionate it if I want. Okay? Good question. All right, back to my test. The neutral atom will always contain what? So out of here, they're all going to be the same number. So I'm just going to put the same number but just note that that is going to be the same for everything. So the same number of N and E, which is neutrons and electrons. B, the same number of protons and neutrons. C, the same number of protons and electrons. Or D, the same number of protons, neutrons, and electrons. So first of all, let's just go back to this thing, the sentence, the question, and what does it mean to be neutral?
No charge.
No charge. So electrons are what charged?
Negative.
And a proton is?
Positive.
Positive.
And a neutron is?
Zero.
Neutral.
Neutral, because that's what we call a neutron. So for something to be neutral, it needs to have either just neutrons, or what needs to happen between the protons and the electrons?
They need to be balanced and have the same amount.
Exactly. So out of these questions, which one tells you, which one makes the most sense? If I had protons, neutrons, and electrons, does that mean overall we're neutral? No.
No.
Okay. If I have the same number of protons and neutrons, what would that make my overall charge?
Positive.
Exactly. If I have the same number of neutrons and electrons, what type of charge do I have?
Negative.
Negative. Okay. So the only way for a neutral atom to be neutral is if it has the same number of protons and electrons. Okay. Nine. Cobalt is element number 27. Okay. Cobalt 60, and that's just abbreviation, is the medical treatment for cancer. How many neutrons and protons? So how many neutrons and protons are contained in this isotope? So how many protons and neutrons make up cobalt 60?
Neutrons.
So 33 neutrons, 33 protons. We have 27 neutrons, 33 protons. Oopsie. We would have 27 neutrons, 27 protons, or we have 33 neutrons and 27 protons. Now, you have to look back. We're talking about cobalt 27. That is what we're talking about. An isotope changes based on the origination of the atom that we're talking about. So for this to be true, we know that 27 has to be involved somewhere, okay? Has to be, because that is where this isotope originated from. We just have to decide, is it a proton, neutron? What is it? Where is that 27 going to lie? Is the 27 going to count for the neutrons, or is the 27 going to count for the protons? Okay, so if we need a periodic table to solve this, which you'll be given, but you need to look at the periodic table. And if we have to kind of figure that out, if he doesn't give you it, but most of the time he'll tell you cobalt number 27. So if I have, my isotope is 60, right? The best way to do this, honestly, is this number is always going to be indicative of the proton, okay, that they give you from the original atom, okay? This number is what we moved to, okay? So all you do is subtract them, okay? So therefore, I should have 33 neutrons and 27 protons. Okay? Any questions on that one? know how to do it. Okay, it's literally just simple math here. Cool. Wait, did I do? Ten. Which subatomic particle contributes least to the mass? Of an atom? Is it the neutron? Is it the electron? Is it the proton? Or is it all? Which contributes least?
The electron.
Why?
Because it's like 1/2000th of the mass of the neutron or the proton, I think.
Exactly. Even simpler than that, how do we get things to stick? I'll show you an example. Here's one atom. That looks like a boob, sorry. Here's another one. Okay. He's negative, he's positively charged, and he's negatively charged. Okay. Who dominates? Does he dominate, or will he? Will he do the attacking, or will he do the attacking? Who attacks what? Does a negatively based atom attack a positively based atom, or does a positively based atom attack a negative when we're building compounds? Nobody? So this is an intro to electronegativity. The more negative you are, the more you seek to become positive or neutral, the more powerful you are, okay? Negative always trumps. So the reason that these electrons contribute less is because they're the ones that are doing the reaction, okay? They are responsible for bringing atoms together to make molecules, okay? So they can't be part of the mass because they're constantly adding, they're constantly grabbing other atoms. That will affect, okay? So electrons are very important for connection of molecules, for atoms to make molecules, okay? So they are the reactivity. They are the source of reaction. Without them, nothing would come together. So they can't be part of the mass because they're ever changing. They're ever doing something or spinning or circulating around the atom, and they're constantly trying to satiate the octet rule, okay? So they can't be part of the mass. Outside of the fact that they are they contribute that millionth of a millionth, right? That's great knowing that, but in general, they're the source for the reactivity of making molecules. So they cannot be part of the mass. Okay, they contribute the least to that because that's indicative that they are stationary, which they are not. Okay, electrons are always moving. Okay, and that would be like the conceptual side of that. So there could be a follow-up, right? All right, now we're going to move on to isotopes. Okay, so which of the following represents, abbreviating, a pair of isotopes? Again, this comes down to terminology. You need to know what an isotope is. We kind of touched a little bit of that when we did the cobalt exercise, but you need to know what it is, okay? And here we go. A, you have 1,1H and 2,1H. Are those isotopes? O2 and O3. Are those isotopes? 14,6 carbon and 14,7 nitrogen. Are those isotopes? Or 3216S and 3216S2 minus. Okay, first of all, if you see anything wonky like that, please don't choose it. Not even, it doesn't even make any sense. Okay, so that's another thing with Richmond's tests. If it's like, what is this -2? You should be like, right? And cancel that right out. So now we only have 3 options. When we're dealing with isotopes, a big hint is that most of them won't change atom names. So this is not going to be something that we're looking for in terms of an isotope, okay? That's like more like radioactive decay, okay? So it can't be C or D. We know that. So now you have to look at A and B, right? And what is the difference between A and B? Yes, Lucy, this is exactly how those exams will be. Organic chemistry, when you get to, I think is exam 2 or 3, that's probably one of the harder ones because it will have molecules that you'll have to identify. But yes, these, if you're finding these to be relatively easy, then you are in good shape. Okay, so O2 and O3, those are actually just molecules. That has nothing to do with isotopes. Isotopes, what's the definition of an isotope?
Differing mass.
Okay, differing mass.
Extra electrons. I mean, electrons and neutrons.
Yeah, and so what are these? Those are completely different things, okay? That's like ozone and oxygen, gas. So it can't be this. So the only applicable answer would be changing in, I guess I should highlight that so it can be consistent, would be the change in the electrons and the mass. So here. So it has to be in this format, and then it will never change. It will never change, like from this carbon and nitrogen, you'll never see it change in that facet because that's the decay. So we don't need to go there. And we'll never see this 2- in it. So right off the rip, just know isotopes change. It's the same form of that element. It just changes in with equal numbers of protons. Okay, they just have different numbers of neutrons. Cool. So
Hey, Liz.
yeah.
Is he gonna go into the difference between like a mass number and the atomic mass?
I think he expects you to kind of know what those differences are, but I haven't seen him go into too much detail about asking what they are.
Like knowing which isotope of a certain atom is more abundant?
No.
Oh.
No.
Okay.
Are you at this point for this answer this question, you just need to know what an isotope is, and it's going to be the change in the number of neutrons.
Okay.
Yeah. Cool. Alrighty, let's continue on. 12. We still have quite a few problems. So if you do feel the need that you have to leave, again, since we all agreed we can record this, it'll be recorded. Thank you for answering the chat. It will be recorded and you can view it later. But my goal is I want to get through, we have 26 questions and we're only on 12, so we still have a couple more to go. So again, if you have to leave, that's fine, but I want to finish it. Okay, and most of the exams should be about 30 questions, okay? Just heads up. All right, number 12, here we go. The half-life, now we're in radioactive decay, and we knew we were getting there. So the half-life, of a specific radionuclide, which you don't need to know, of something, I'm just going to have specific X, you don't need to know that terminology, is 8 days, okay? How much of an 80 milligram sample will be left after 24 days? Okay, first of all, you need to remember this. Okay, this is going to be the number of half-lives from the given time. So what I'm saying is how much you need to start with first is to figure out the half-lives, we have to deal with this number and we have to deal with this number, right? So I would take 24 and divide that by 8. And what does that give you? My phone died. Sad. What's 24 divided by 8?
3.
What?
3. 3.
Cool. I'm a calc teacher, but I don't feel like doing algebra, so thanks. 3. Okay. Now this number is n. Okay, that is your n. It's cool. We get it? Follow that? All right. Now we have 1/2. Okay, that's a 2. To the third, and then times the amount. So what do we get? Can somebody compute that for me?
10.
Right. Any questions on how I solve this? Please remember, he may, let me just double check the cheat sheet if he gives you. No. So that is one thing he didn't give. He might update this to give you that, but I don't think that half-life is on here. So if I were you, and I would probably do this, remember this equation, okay? And that n is found when you're talking about the days or the time. It could be in hours. If you have something that has a half-life of 8 hours or 12 hours, and you want to know how much of certain dose is left in the body after 24 or 48 hours, you'll just take the 48, divide that by the 12, which is the half-life, and that'll give you the number of half-lives. So there are 4 12-hour half-lives in a 48-hour period. In this case, there are 3 8-hour half-lives in 24 hours. Okay? Then we're going to take that 1/2 to the third times the amount, and that should give you 10 milligrams. And the options that he had were A, 20 milligrams, B, 2.7 milligrams, C, 10 milligrams, or D, 40 milligrams. Okay? So even though it's multiple choice, you will need to do some work. Okay? So just remember that for half-life and you'll be Gucci. All right. 13. Any questions on that? Seriously, just remember that. Okay? Now the next question is, what radioactive particle is missing from the following nuclear reaction? So we just did half-life, now we're into alpha-beta decay, okay? You can see this trend is still going. So we have what radioactive is missing from the following. I'm just going to say reaction, but we know we're talking about nuclear reaction. So here it is. We have 99 over 42, and you don't even need to know what the frick these things are. You just have to know what you're looking for. Does that make sense? Okay, so I have this. What am I missing? Key things to look at. This and this. It doesn't matter what everything else is, the M, the O, the T, C, the weird stuff. You need to look at those numbers. So I went from 42 to 43, okay? So if I'm doing that, Mackenzie says, will you send me the link to your YouTube as you're posting this too? Oh yes, I will also send out an email with my YouTube link. I'll send it to everybody in the class because I didn't ask for anyone's emails today. So I'll send it after this. I'll upload it and give you the link. It takes about maybe 5 hours to upload, I think. 3 to 4 hours. But yeah, it'll be on there end of day today. Okay, so pay attention to these numbers. So we went from 42 to 43. So when we're gaining, what is that? Is that indicative of alpha or beta decay? We already had somebody say beta decay. So what is the formula for beta decay?
It's like the, oh, never mind. You
Does
guys.
it look like this? Is that what you're gonna say? Yes. Okay, beta decay always deals with this guy down here. So this will stay the same, but this will gain in terms of add that electron. Okay, we're talking about, even though an electron is negative, we add to that value. Okay, so negative, we add. So this would be a beta decay, so your formula would be this. Okay, so the options were 1 over 0 n, 0 over negative 1 e, 1 over 1 p, that doesn't even make any sense. But then my favorite is 4 over 2 ag. Okay, what is this?
Alpha.
Exactly. So what do you need to know about this? You need to know the formulas, or at least remember the visuals for the formulas for both alpha and beta decay. Notice how I didn't ask you to do it or solve it or make a new number or find it or whatever. He just wants you to know the formulas. Okay, that is what you would add to show that this is in fact beta decay. Okay, cool. 14. Also, I want to put something up here. Total. Does anybody remember the total amount of students that we had today? The last time I looked, it was 30, but I think I had more than that. How many came? Do we know? I'm gonna put 30 plus, so I can just keep tabs. I like to make sure I get the word out. Okay, the form of radioactivity. The form of radioactivity that penetrates matter the most easily is what? The most easily. A, beta, B, alpha, C, gamma, or D, protons. I want you to really think about this. Go ahead.
I was gonna say, by easily, are we talking about like how far it penetrates?
Just the ability to get in this, to penetrate.
Is it gamma?
Why?
I don't know. I just remember this from the homework. I can't remember why.
Okay, I want you to think about it. You're all going to be nurses. If you have a cancer patient, what type of treatment do we give them?
Radiation.
Okay, and what are the only types of waves that go through, are used for that? Gamma. Okay, everything else in terms of alpha and beta, those kind of particles are getting dinged off my phone, right? Here's a gamma or an alpha or a beta particle, beta wave banging me. The smoke detectors do that. The fire alarms do that. Those are tiny little infractions that are bouncing off of us all day long, but they're not enough to do damage. And so that's why they don't really penetrate, because they're just not strong enough. Okay, which one goes the most easily? Gamma. That thing can go right through you and beyond. Okay, it could go through a wall. It could go through 2 brick walls. Okay, it just cuts right through. So gamma, most easily. Okay, everything else just kind of bounces off. There has to be enough. Okay, next question, 15. Oh, dang it. Okay, 15. Which of the following elements contains 6 valence electrons? Okay, this one is more a combination of periodic table and trends and understanding how to use a periodic table, okay? So even though it's way down there, we need to make sure we know how and what we're looking at the periodic table and what those rows and columns and all the numbers on the sides mean, okay? So which of the following takes 6 valence electrons? A, is it phosphorus, chlorine, silicone, or sulfur? So which one has 6 valence electrons? Do we know what a valence electron is?
The outermost electrons in the shell.
Right. So how do we find that?
It's the same as whatever group number it is. So like group 6
Exactly. And
element.
what's a group number? And how do I find a group number?
Group numbers are along the top of the periodic table.
So what group number is oxygen?
6.
6.
What group number is helium?
8.
8.
Okay, does everybody know what I'm talking about in terms of group number? It's okay to say no. It's okay to say no. Okay, so if I just want to, I'm gonna be really silly and I can't really draw a periodic table, but I'm gonna pretend like I know what I'm doing. Oh God. Just bear with me for just 2 seconds so that I can help those that don't necessarily want to say anything. Oh, hey, that's nice. I didn't know it did that. And then nobody cares. Okay. And then 1, 2. And then where's my 3? Do I count this?
On the other side of the.
Not this section. Don't count this section, right? 3, 4, 5, 6, 7. Just pretend, and then 8 is noble gases. Okay? I didn't put enough lines in there. I told you it was going to be chintzy. But you get the gist. Don't count that. What is this section called?
Transition metals.
Yeah. Bye. We won't use them because you're not organometallic scientists. Okay? So don't worry about this stuff. But this is the number. 1, 2, 3, 4, 5, 6, 7. And 8 is noble gases. Okay? So now you just need to go in there, find P, so phosphorus, chlorine, silicon, and sulfur, see where they are, see which one is in the 6th row, in the 6th column, and you've answered your question. Okay? So in that case, what's the answer? Which one has 6?
Silicon.
Phosphorus. Wait.
6 valence electrons. Which one?
Not silicon, sulfur, sorry.
There you go. Okay. Are we good with that? That will be on there. There might be 2 of those on there. Okay. So please practice the trends on the periodic table. Things need to know. Group number is valence electrons, atomic numbers. Maybe familiarize yourself with, CONF, carbon, oxygen, nitrogen, fluorine, calcium, Ca, magnesium, sodium, just aware because those are the examples he uses the most. Okay. Cool. All right. We're almost done, peeps. I know my voice is getting, oh crap. Tired of it. 16, an ion with atomic number of 34 and 36 electrons has what charge? What's its charge?
-2.
Why?
Because we have 2 more electrons than we do protons.
Okay, so which one is my proton value? Because I did not tell you in this question.
The atomic number.
I told you an atomic number. So you need to know what makes up the atomic number. Okay, so I think this answers the question that you may have asked about if we need to know atomic mass, atomic number. You need to know like what makes those parts are of it. Okay, so in the atomic number, we have 34, and I'm telling you 36. So yes, it would be -2 because 34 plus 36, well, minus 36. You can either think of it in terms of this, because this value is indicative of electrons, or you just know that you're dealing with electrons, and electrons have a negative value. So I like to just think of it as normal, as subtraction, and that's going to give you a -2. Okay. Any questions on that? Sorry. I do have a 4-year-old. She's down there. She's asking for food. Oops. Okay. Who cares? Don't feed the kids. Don't feed the kids. All right, we're almost done. 17. The reaction of magnesium and nitrogen produces what? So we're taking this plus this. What does that give me? 2 atoms. Now we're making a compound. What is it? Or a molecule, right? 2 atoms together make a molecule. So what is this new molecule? Is it Mg2N3? Is it Mg3N? Is it Mgn? Or is it Mg3? Not like that. N2. Now, things to look for. Why would you even see subscripts in here? Why would we have subscripts? What does that mean? That we would have to balance that out. They would have what?
The charges.
Yes, okay. So when you're putting 2 atoms together, you need to look at the charge of them. If one is -1 and one is +1, then together they're 0, right? And they're happy. The goal for 2 atoms to come together, there needs to be equal, okay? They have to come together and be equal. So in this case, you have to look at the periodic table and check out the charges of both magnesium and nitrogen and see what they're at. +1, -1, +2, -1, right? What are those charges on the periodic table? For me to put them together, they have to be equal. If magnesium, what's magnesium's charge?
+2.
2 plus,
2 plus.
What's nitrogen's?
3 minus.
So nitrogen's is 3 minus?
Yeah.
Okay. Did everyone find that? Yes, no? Everyone found it? Okay, so if magnesium's is 2 plus and nitrogen's is 3 plus, then I need to have 3 magnesiums to cover the nitrogens, and then I need to have 2 nitrogens to cover the magnesiums. Vice versa, right? So I just cross them and say, if there's 3 here up at the top, then on the opposite, their counterpart needs it, the bottom. So you need to flip them. Okay, and that was how we would balance out. So for that, it would be D. You need 3 magnesiums to balance out the 2. Okay, you can also say, okay, well, 3 and 2, say, do math that way, but personally, I like the easy route. Right, 18. The total number of valence electrons. So what's the total number of valence electrons in this molecule? Is it A, 26, B, 18, C, 20, or D, 24? What is the total number of valence electrons? So what you need to do, split them up. That's 3 different atoms. You need to figure out from there, right? We told you what valence electrons are, so how do I figure this out? What would be the answer?
$26.
26. Did anyone not find 26? Again, we just look at the group number, okay? What did you do for the F? I have 2 Fs, so what did you do?
The valence electrons for F twice.
Yeah. So if you have 2 something, you just add it twice. So if I had 3 valence electrons, never will be, but 3 valence electrons for fluorine, and I have 2 fluorine, that means I have 6 total valence electrons for those 2 atoms. Okay, so don't forget to do that. Cool. 19. Dang it, I mean. 19. Which of the following formulas is incorrect? So now I'm going to give you cobalt 3. And I'm asking you which is incorrect. CO2, O3, COCl3, COPO4, COCO3. How do I even begin to do this? Cobalt 3. How do I begin to do that? Which is an incorrect formula? Nobody knows how to do that? No, 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 no. So the question is asking, you have to think about it, a compound. So what's cobalt near? What's cobalt near on the periodic table? Nothing? Yeah, nothing? Okay. So first of all, I'm not going to ever have cobalt and oxygen together. It's not going to work. If we look at where cobalt and oxygen lie on the periodic table, there's no way, based on where their valence electrons are at, that would ever be a thing. Okay. Second thing is, again, we have CO3. This is never going to be anything, because I've got cobalt, carbon, and oxygen together. Okay, that doesn't make any sense either. Here I have copper or cobalt and, like, what is PO4? It's some sort of phosphate, right? So copper phosphate. So in this sense, we have to deal about metal, non-metal. We have to think about wherever you see a cobalt, the only thing it's ever going to want to go with is chloride. It doesn't matter. This is just kind of like a memory-based thing without going into too much detail about how necessarily to solve it on the periodic table. But you're not going to ever see cobalt and oxygen together. Just that never will work. So the only thing that makes sense is that we have cobalt chloride. So we have for 3 chlorides for the cobalt. Okay. And that, again, is just dealing with your transitions and trends on the periodic table. I can go in more detail about it, but this one, just know. I'm circling it up here. Just know that. Straight up, just know it. Okay. Next question, and then we're done. It's going to be tetrahedral. It's going to be about geometry. So now we're getting into the drawing of things, and then we're almost done. What is the molecular geometry of NH3? Okay. You have tetrahedral, you have trigonal, pyramidal, you have trigonal planar, and you have bent. NH3. For this, you need to draw it out, okay? You can't just go in whammy slammy. When I have a nitrogen, he's the only thing. Helium, hydrogens always do last, okay? Hydrogens are your fillers. Every time that you're doing Lewis structure, they're always last. Please never start with a hydrogen. Always start with the most electronegative or the only atom that's outside of hydrogen, okay? So in this case, we only have 1 nitrogen, so I'm gonna start with that. And in this case, we have 3 of them, okay? So if we're looking in terms of drawing this, would we draw it this way ever? No, because hydrogen only can make 1 bond, okay? So that would never work. Would we draw it this way? No, because you have to think these are all atoms and they don't want to be next to each other. Okay, they still have space. So you want an equal distribute of energy and throughout the particles that are throughout each atom. Okay, so this is too heavy on this side. We have nothing going on over here. It's too heavy. Okay, so naturally speaking, you would either draw it angled like this or you would draw it like this. Now, if I drew it this way versus this way, what do you notice? What's the difference between this one and between this one? Which one's more even? Look at the distance here. That's 180 degrees. This is like 90 degrees. But this and this and this are all the same. Therefore, is an equal molecule and it's very happy. It's very stable, okay? This is 180 degrees. So we have one side where half of that molecule has 0 electron cloud, okay? So why would I ever draw it to look like this, even though it could work, you know, it looks kind of happy. This here, though, the bond angle, and that's the key, bond angle, okay? That's where you want to think about. So in this case, this one right here is called the trigonal planar. Oh, I'm sorry, not planar, pyramidal. See, I even get them mixed up. Because it looks like a pyramid. Okay? Even though this resembles a pyramid, it's not, right? This is a pyramid because the whole thing is a pyramid. We're still missing out that whole thing. So the answer for this question is trigonal pyramidal. That would be the natural geometry of NH3. Okay? 21. There is a table of electronegativity values on the front of this exam, and the concept was invented by Nobel Peace Prize winning chemist Linus Pauling. Provide a complete definition of electronegativity. Define electronegativity. Now I'm going to tell you this definition and write it down verbatim because this will also become something he asks. Are you ready? I'm going to write it in red, and I'll write it clear. The ability of an atom in a chemical bond to attract shared electron density to itself. Okay, there you go. That is the definition of electronegativity. You won't have to write it out, but you'll need to pick at it in a list of multiple choice. Okay? All right. 22. Now we're going to do a DA problem. Again, it will not be work, it will be multiple choice. You will have to do the work. Okay? Determine the mass in pounds of 1.00 gallon of gasoline, where the density of that is equal to 0.75 grams per milliliter. Also know for quart equals 1 gallon. This will be given to you. 1 liter equals 1.07 quarts. And 454 gallons equals 1 pound. He will give you these, okay? He will give you what their conversions are, but you need to know how to convert, okay? So here's what we're gonna begin. Our goal is we wanna determine the mass in pounds, okay? So we know that pounds should be our final unit, okay? So I'm going to start here with, I'm gonna do it in red, 1.00 gal because that's what we were given. And I know that for every 4 quarts, there's 1 gallon. So now gal and gal canceled out and I'm in quarts. We know that there are 1.07 quarts in 1 liter. So now my quarts have canceled out and now I'm in liters. We following? And now I know that there's how many milliliters in a liter. That's something that you need to know. You can write it this way, 10 to the third, or you can say 1,000, right? We good with that? This is just scientific notation, okay? Times, now we're in mils because liter and liters canceled out. There are, I'm telling you, look it up there in density. You're like, well, where do I go with milliliters? Now we're in milliliters. Well, I'm telling you the density in milliliters is 0.75 grams per milliliter. So now I have mils on the top. So now I'm gonna have 0.75 grams per 1 ml. And this ml and this ml cancel out. And now I'm in grams. And then from my grams, okay, we know that there are 454 grams for 1 pound. All of that math, grams and grams cancel. We're ending in pounds. We should get 6.2 pounds. Okay? Please follow your units. Please write your units. Otherwise, you'll get lost. Okay? Even when you're not doing the math. For work, on the exam, and you're just trying to solve it, please just follow it as you do it. Any questions on this? Okay. 23. Draw Lewis structure. Now, again, you won't be drawing, but you need to pick, okay? You'll need to pick from the pictures which is the right one. Of these 2 atoms, we'll have one is SO2, and the second one is H2CO. First things first, determine valence electrons. Okay, so for SO2, I have 18 valence electrons. And for H2CO, I should have 12 valence electrons. Don't ask me how I know that. I've done it for a really long time. But go ahead and update and validate on your periodic tables that you did get 18 and 12. Okay? After that, you need to determine the shape. Remember, central atoms are usually solo. I have 2 oxygen here and only 1 sulfur. So I'm going to start with the sulfur. Okay? And then I'm going to say, okay, I'm going to have an O here and I'm going to have an O here. All right? And you're like, well, Liz, how did you know to put the O there, and why don't you make it equal so it looks similarly like this, right? Why didn't I do it that way? Because you just told me that that's 180 and that's 180, because we did not fill out our valence electrons yet, okay? So here's what. So I'm gonna do these in blue. That is 2, this is 4. These are called Lewis dot structures. Please actually put dots on, okay? 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 14, 16, and then 18. Do we agree with that? Do we agree?
Isn't sulfur missing a pair?
Exactly. Okay. So, and so that's what most people will do, is they'll just start dotting around and they'll make oxygen. Another person though. They'll just satiate everything. What can I do though? So if we take a look, sulfur only has 1, 2. I'll do it in a different color because we're talking about that. He only has 2, 4, 6. So he doesn't have 8. All right. So what we need to do is we need to change that. So I would take away one of these, make this a double bond. No, I'm busy. Now let's look. 2, 4, 6, 8, 10, 12, 14, 16, 18. This has, this oxygen is satiated by 8. This guy is now satiated by 8. And this guy is satiated by the 8 octet rule. So meaning 2, 4, 6, 8 electrons. Now, are we good with that? Everyone clear on how I did it? Form double bonds, okay? This shape would be considered bent, and it's bent because it's not making a necessary pyramid, because if I were to redraw this in terms of just electron clouds, this would be its electron cloud. Then we would have oxygen that would have an electron cloud here. And then we would have oxygen here with an electron cloud, these circles being the electron cloud. And this one, this lone pair, is what's making it uneven. And so it's going to give it a bent feel, okay? So this is bent. Now let's do H2CO. I said that there were 12 in this one. So again, I would always make carbon my main source, carbon the center. Let's give carbon 4 bonds. So we have 12 valence electrons. I'm just going to do something that looks like this to begin with. And then oxygen and hydrogen. We know hydrogen only forms 1 bond, okay? So this is pretty parallel here, but this gap is a little bit too big. And you'll start to know when you're drawing geometry, make things relatively equal. Okay, so for that to work, we would actually need to bend these guys out. And I have 12 valence electrons, so there's 2, there's 4, there's 6, there's 8, carbon's happy, there's 10, there's 12. Okay? Please do not make, and this guy is, trigonoplanar. Because planar coming from the fact that he has this double bond and this double bond, they don't move. They don't even rotate. So you can move them in space this way, right? Hinging, but they actually don't spin. They're kind of stuck there. So they're heavier, okay? Because they're more electron dense. So when you have other things like on this sulfur that they can kind of wiggle and move around, that double bond's gonna kind of keep them stuck. Cool? So we have trigonoplanar and bent. And last question. Draw a 3. Instead of drawing, it'll probably say determine the 3-dimensional structure for this CH2F2 and state whether the molecule and state whether polar or non-polar. Okay? Again, always start with carbon. It's organic chemistry, we always start with carbon. Carbon is the backbone of everything. When we get to that section, you'll know why. Always start with carbon, okay? Then do oxygen, nitrogen. Always start with carbon though. So here's carbon. And if I were you, I would know that carbon only can make 4 bonds. So boom, and boom, and I'm gonna give these 2 hydrogens. So that knocks that right off the way. But I have these fluorines. Now, what do we know something about fluorine? And we look on the periodic table, he's all the way to the right of the periodic table. As we move to the right side of the periodic table, electronegativity increases. So if here's my ghetto periodic table. That actually turned out pretty good. This increase in electronegativity. Increase in electronegativity. Fluorine is very electronegative. But as we move from left to right, right, and I was comparing, say, hydrogen and fluorine, right? Fluorine is obviously more electronegativity. So increasing in negative and electronegativity from left to right and from bottom to top. Okay? That's how we increase in electronegativity. Why does that matter? Because that's telling you what's happening with fluorine here. So fluorine is a very electronegative atom. So he's going to be bouncing off the hooks. Okay? So when we're talking about a three-dimensional structure, these wedges and dashes are indicative of where they lie on the plane. And if everybody can just look up at my computer really fast, and carbon's always going to be the center molecule, so we're never going to really show carbon, okay, because he's always in the middle. Our molecule is doing something like this, where we have my pens, two pens are coming at, one pen is coming at you, right? But the back of the pen is facing me. And that's what's happening with these fluorines. So one fluorine is facing you, and one fluorine is facing me, and then hydrogen is facing that way, and the other hydrogen is facing out, okay? So these sticks like this, when you see that, these are going to lay flat on paper, okay? This one, it doesn't matter if it's a wedge or a dash, or the lines are solid. It doesn't matter. It doesn't matter. But you just have to know, differentiate that one is coming out of paper. So if you were looking at a piece of paper, here's the piece of paper, one would be coming out at you. And then one is going behind through the back of the paper, okay? So if this is my paper, one is coming at me, one is going out the bottom, okay? And that's how you're gonna be able to do a 3D drawing of something like that, especially with high electronegativity. All right. Last thing to note, be aware of density. Know that density equals mass over volume. Know that we can manipulate that to solve for mass or for volume. So you can, if you solve for volume, you can solve for volume, or we can solve for mass indifferently, okay? And it's all through this same one. So when I'm saying that is, if I had density equals mass divided by volume, and I want to solve for volume, then I would multiply by the volume, multiply by the volume, volume times density equals mass, okay? Divide by density, so we can say that volume equals mass over density. And that's just one of the ways to manipulate the equation. But just know that from this equation, okay, you can manipulate to solve for volume or mass. Okay? That, my friends, is what will be on your exam 1. Okay? Not all 100% these questions, but you need to know these concepts that we did today. We did 25 questions, 24 questions. That is very much what it'll be like for the exam. If you feel comfortable where you're at, what you learned today, then incredible, awesome. Just keep practicing and pound out your mastering chemistry and your problem sets, okay? If there's something from today's session that you are very stuck on, even if it's about just trends on the periodic table, shoot me a message, okay? Other than that, it's 5:40. We killed it. It was a little long, but I will upload this to YouTube by end of day today. Your test is until Wednesday. And nonpolar? Yeah, that's a good question. I should do that. So this one, nonpolar, indicates that there's no pulling. Polar is that there is pulling. So we have 2 electronegative atoms, so they're pulling. Therefore, this molecule was polar. Okay, that's a trick to remember polar and nonpolar. Pulling something is something more electronegative? Yes, so it's a polar molecule. If there's no pull, this would be no pull. This would be a polar molecule. Okay, C4, CH4, a methyl group. That is a non-polar molecule because the dipole moments, there is no dipole moments. There's equal share from the central atom. Here you have a dipole moment here, and here you have a dipole moment here. You have double poling, okay, between two electronegative atoms. So good question.
Will there not be any questions about moles and I don't know. I was struggling with the problems at the end of chapter 3.
Like molarity.
Yeah.
I'm going to take a look at the exam one before he makes it. And so that's why I'm holding a second review tomorrow. So I will definitely, if there is, in that sense, I will send out an email telling you, like giving you an example problem and that you should know how to do that. From my previous, I don't remember us having that on there. So
Okay.
I believe that comes
Will
out.
will the second review tomorrow be going over the same material, or will it be different questions?
It's going to be different questions, but similarly the same content. Yeah. Any other questions? Comments, concerns? Please don't stress out about your tests and your exams. Trust me, your first one, everyone always gets really scared and then they dominate, okay? I would be more concerned for exam 2 and 3 when we start getting into organic chemistry and biochemistry, okay? Take your efforts right now, get ahead on your problem sets and get ahead on your mastering chemistry, okay? This first exam will be breezed. You need to get ahead of the mastering chemistry and you need to do the problem sets, okay? Get those points, get that stuff out of the way. Submit it as fast as you can. If you need help me, if you want me to check it over, send me an email, and then I'll help you go over and guide you. But get that stuff out of the way so you can focus on when we start dealing and diving into organic chemistry, okay? It's killer. That's where everybody loses their marbles, right? So that's coming up, and I'm just preparing you for that, okay? Again, I will email everyone again about our review session tomorrow. I'm gonna give you a link to my YouTube, and then I'll have this uploaded probably tonight. I think I'll also include in the email a PDF of maybe if you want a PDF, actually rather, if you want a PDF of the notes that we took today and you didn't get it all down, message me. I'd rather not pass my PDFs out just because they could be potential exam questions and I don't want to be held responsible, but just message me and we'll work something out. Okay? All right. With that being said, have a lovely night. Work hard. And I will see you.
Thank you.
Thank you.
You're welcome.
Yeah.
You're welcome. Okay. Oh. Okay, I can do that. All right, who else? Yes.